This video is going to have a look at constructing piecewise graphs to match the context of a given question. So a piecewise graph is a continuous graph that's formed by two or more linear equations, and these equations are joined by points of intersection. So let's have a look at how do we construct a piecewise graph. So in this example, we're taught that an empty tank is being filled from a mountain spring. For the first 30 minutes, the equation given by volume V of water in the tank at time t minutes is V is equal to 15t. So that means it is filling at a rate of 15 liters per minute for the first 30 minutes. And we can see that the domain for that equation is t is in between 0 and 30, which means that time is between 0 and 30 minutes. So after 30 minutes of water filling, the spring slows down. For the next 70 minutes, the equation is given by the equation of V equals 150 plus 10t. So that means it slows down and it's now filling at 10 liters per minute. And we can see in our equation that the domain of t between 30 and 100 matches the question for the next 70 minutes. So starting at 30 minutes and then adding on 70 minutes gets us to our finishing point at 100. Now, because it is greater than or equal to 100, we know that our graph is going to have a definite ending point at 100. So the question is asking us to construct a piecewise linear graph. So they've given us a lot of information that we can be using in constructing this graph. The graph is going to consist of two equations. So our first equation, when it's filling at 15 liters per minute, and our second equation, when it slows down to 10 liters per minute. So for the first equation, it's going to finish at 30 minutes. And at 30 minutes, there's going to be 450 liters in the tank. And we know that because we're doing it for 30 minutes at a rate of 15 liters. So my first point of intersection is going to be at 30 minutes. So 30, and it's going to be at 450. So that is my first intersection point. For the second intersection point, or where my graph is actually going to finish, because there's only two equations. So at 100 minutes, the amount of water that's going to be in the tank is going to be 1,150 liters. And this is calculated by starting at our original 450 starting point, plus 70 minutes filling at 10 liters per minute. So 450 plus 700 is 1,150. So that is going to be our endpoint, which is 100 and 1,150. So now that we have our 2 points of intersection, we can go ahead and graph that onto a Cartesian plane. All right, so now that we have our Cartesian plane and we've got our intersection points of 30 and 450 and 100 and 1,150, we can go ahead and start graphing. Before I start my graphing, I might add in some labels for my X and Y axes. So down the bottom, we are going to have minutes, and that's going to be T. And then up the side, we are going to have volume, and that is going to be in liters. So when I am graphing a piecewise graph, I start off with my point of intersection, so 30 and 450, and go ahead and mark that in. And then I'm also going to mark in my endpoint. So 100 and 1,150 right up the very top. Now that I've got those 2 points marked, I can go ahead and graph each of the required equations. So the first one, V equals 15t. I'm going to join up my 0, 0 origin and my first intersection point, because I know that when I'm filling up the tank, it is going to start at a volume of 0. And then after 30 minutes, it's going to have a volume of 450. And then I can go ahead and complete my second equation. So V equals 150 plus 10t. I'm going to go ahead and join in my remaining 2 dots. Now, because we're given domains with definite endpoint of 100 minutes, I don't need to put an arrow on the end of that line. So that is my completed piecewise graph for the question in the example. we can see that we've got our two equations, v equals 15t in green, and then v equals 150 plus 10t in blue.